Microsoft guys gone? Why were they doing .NET in the Java time? Isn't that at the beginning? Oh, they're not done. All right. I'm here to talk about Eclipse RCP today. Anybody uses Eclipse support today? Seems to be the most prevalent IDE so far. Any NetBeans users? What else is there? IntelliJ IDEA? Well, you have to pay for that one, so I'm cheap. I don't like to pay for stuff. So Eclipse RCP is a rich client platform. By the way, Brian Sam-Bodden. I introduced myself like 8 times today, so I'll skip that. So I'm going to start with describing what a rich client is. That's not a rich client. So the Microsoft guys are gone. Notice the background? Maybe this is a rich client. Google. So really, a rich client is an application that has the advantages of the old fat clients. Anybody did like Delphi, Oracle Forms, Visual Basic? We know that when the web came to be, we were doing all these applications with data tables and graphs and all these things, and then the web appeared, and it was very primitive, and then they said, we want that on this. And it's been a painful progression to get there. I mean, those guys were showing things like Silverlight and Flex and things of that sort, kind of make life easier, but still, you have a full-blown Windows application in there. Why do you need the browser? So the idea is to have the advantages of the old fat client applications, but also have the flexibility of the web applications, not needing to have an install or have an install that always works and it's very simple. Have the ability to update the application dynamically, update the application via the web. In most of these applications, the level of interactivity you have real-time updates, you might need the application to work disconnected. So that's where something like the Rich Client Platform can help you, because we can get really far with Flex and Silverlight and Ajax-enabled applications. But what happens when you have a disconnected client? There's no internet connection. And most of those browser-based technologies kind of break down. So a rich client has powerful widgets, having components that are closely related to the components native to the platform, it's very helpful. When we have only emulated components, they're usually the real user experience is sluggish. So the components that are native to the platform, so if you're using a Windows machine, using a native Windows 3 component, it's much faster than emulating one. But if you're having a framework that can switch between the native Windows component of a 3 versus the one on a Mac versus the one on a Unix machine is a really good thing. So we still want platform independence. That's the reason why Java it became so popular, that we could have an application run in one platform and then take it to another platform and have the same application still running with the same performance and capabilities. The difference with something like Swing, for example, how many here are Swing developers? All right. I used to be a former Swing developer. I'm in recovery now. But the thing with Swing, it's really good now, but it was a painful evolution to get there. And Swing applications, out of the box, they look ugly, and they look like they don't belong. So you have to go through a lot of work using frameworks like JGoodies or any other one, the look and feels out there, to tweak things to the point that they can sort of look like the platform you're running on. Given most of us are forced, Microsoft guys are going again? Yeah. Most of us are forced to deploy our applications, even if they're Java, to Windows, because it's the most prevalent platform in the enterprise. But every time that we did a Swing application on a Windows platform, they never quite looked right, and the users noticed that. They're like, what is this thing running on my machine? I don't like it, it feels strange. How many of you remember having seen a Swing application completely grayed out, so you can resize it and nothing will be there, and then 2 minutes later it goes, and here's the application. So the Swing development model was a little too complex for the average developer. I came from doing Delphi development, and going from Delphi to Swing, it was a nightmare. Things were simple, they made sense, and Swing to me was sort of an overly academic exercise. A lot of listeners, a lot of patterns, a lot of interfaces, a lot of parts of the API that nobody really used. Anybody tried to do drag and drop in Swing like 5 years ago? Painful too. So the idea is that the Eclipse platform brings SWT and JFace into the equation, which are, they utilize the native components of the platform much better. So the applications kind of look more natural in that, like they belong in that operating system right out of the box. So of course, we also want to have one-click install for self-updating capabilities. Having to distribute like an install shield or something like that, it's something of the past. Everybody wants to go to a web page, click on a button, have a Java web start, or have some other way to dynamically install the application, get all the dependencies. And some of those things, we couldn't do those with the fat clients of the past. So a rich client has those capabilities too. And again, tight integration with the OS, the ability to use a native drag and drop, the ability to use all the powers of that graphic card that you pay so much money for on that machine. And of course, a rich user experience. So rich client applications are tailored more for the power user, the user that spends more than a few hours on that application, rather than the casual user that, for example, they had the example of the airline booking. Well, I'm a casual user of airline booking. I go there, I do something for 10, 20 minutes, and that's it, I'm done. But somebody like a stockbroker needs an application that's going to be running very long user sessions, running pretty much all day. And web applications are still not very good for doing that type of interaction. So that's when you want something like a rich client. So the typical rich client architecture, we have widget libraries and we have application frameworks. And this is a big difference between the applications today and back then when we had fat clients. Back then we didn't have application frameworks. We only have widgets and we wire them to databases the best way we could. Now we have more of the MVC type of frameworks for rich client development. And of course we have fine-grained communication with backend services, but we can also have fine-grained communication with local services that have a local cache of data. So your users can work disconnected. A typical example that I've encountered is in insurance companies. They have insurance agents that have to go into areas of the country where there's no data, no internet connectivity. So they have to work disconnected, and then when they reconnect to the central office, sync everything back. So that type of scenario is very painful to accomplish in a web-based application. So a good friend and mentor, Dave Thomas, basically always said the browsers are dumb. And if you use a browser, we're going back to the whole green screen terminals of the 60s. They're just in color. But so it's like putting lipstick on a pig. And I have to put that picture there. It's too good to pass. So you might need a rich client if your application is targeting power users. If you're doing something that is very simplistic, where you have a lot of users in very simple use cases, in user interaction that lasts minutes, not hours, then a web application might be a good choice. But if you're doing the typical a power broker, a Wall Street application where somebody's actually dealing with real-time updates, you will probably want to use something like a rich client. Responsiveness and expressiveness are definitely critical. And the graphics capabilities usually will surpass what the browser can do. So disconnected clients, like I mentioned, it's a big factor. And getting some of the features of the backline applications with the cool things that we have from the Web 2.0 applications, like not having to distribute and install and being able to update the application dynamically. So that leads us to talking about Eclipse as a platform. Now, we all know Eclipse as an IDE, and it's a fairly good, decent IDE, and it hides a lot of power under the covers that most people don't know about. And the cool thing about Eclipse is the plugin system under the covers. So in Eclipse, you have a collection of plugins that work together to accomplish, a Java IDE in a specific form factor. But a lot of those pieces of functionality are reusable in applications that are not IDE based. They don't have to look like an IDE. That's a typical misconception of Eclipse RCP, that if you build an Eclipse RCP, your application has to look like the Eclipse IDE. Well, it doesn't have to. It can look like iTunes, it can look like anything. So Eclipse is a really good platform for innovation. That plugin system under the covers, those plugins are dynamically discovered. They can update themselves. They can load themselves when needed and unload themselves when no longer needed. So there's a lot of flexibility in the platform. So for those of you that are not familiar with Eclipse, there's a couple of UI elements that you will have to be familiar with to work with Eclipse RCP. But you have the typical things that you see in an IDE, like a shortcut bar, a toolbar, editors and views, and collections of editors and views become perspectives. And of course, we have the workbench, which is the actual window with collections of perspectives and views and editors. So to work with Eclipse RCP, you need to know two other technologies. SWT, which is the standard window exposure. In SWT, it's sort of in competition with AWT and Swing. In the Eclipse world, we have SWT and JFace. And in the Swing world, we have AWT and Swing. And for those of you that want to know why one is better than the other, you can ask me after the talk, because that's a long conversation. But I do agree more with how they implemented SWT than the way that AWT and Swing were implemented. But forgetting that, SWT gives you all the native widgets that the platform has, and it will, like Swing, it will emulate the ones that you don't have in the platform. The difference is that in SWT, the connection to the operating system is a very thin pass-through API. So all the changes are dealt with in Java code rather than C code. So in SWT is what powers Eclipse. And it wraps all of the operating system widgets, emulates the ones that you don't have, and has a thin pass-through API to the OS. And you can, of course, like Swing, you can create your own components based on other components, or on a canvas where you can draw, whatever type of, with a Java 2D like API. The thing that I like about SWT is that applications really look much more native right away. For example, in Windows XP, if you're using Windows XP themes, and you switch a theme, SWT can detect that. And the widgets can change to look like whatever theme you're using. If you're using Swing, that's a whole different story. So one of the things that really sold me on SWT was the API. The API is very simple, it's very clean. SWT widgets are closer to the metal. They're not like Swing widgets that have, or components, that have an MVC pattern built in. So these are very simple widgets. On top of SWT, you have JFace to do that MVC type of behavior. But JFace doesn't hide the SWT components, so you can do simple things when you need to, and when you want to do something more complex, you also can do this. You can mix and match between complexity. Not everything has to be an MVC pattern. So there's so many more less layers of indirection than Swing. So here's a screenshot that has some of the components you have available out of the box: calendars, HTML editors. One of the things that, one of the good examples that I bring all the time about Eclipse is in Swing. You guys remember using that horrible web browser widget in Swing that nothing ever worked. Not even applets would work on the Swing browser. Well, the things that SWT does is, rather than reinvent the wheel, building a whole browser into a component, they use whatever the operating system has. So if you're on a Macintosh and you're using Firefox or Safari, you can have the choice of telling SWT, use Safari or use Firefox. And you have a full-blown web browser, but with all the hooks that you need into your components. And if you're on Windows, it would use Internet Explorer. But then, of course, I can't guarantee your application will work fine. So that leads us to JFace. Yeah, I should probably stop bashing the Microsoft, given that they're responsible. So JFace gives you the Swing-like widgets that are model driven. You have the MVC pattern. So when you want to have a model emitting events and changing the views of different components, that's when you use something like JFace. But the cool thing is you can mix and match JFace and SWT, so you can have lightweight widgets when you need them, and the heavyweight widgets that are model driven in the right place. So again, JFace gives you also a lot of reusable components like dialogues, wizards, all the things that we kept on rebuilding over and over in Swing. How many times have you built an about box for a Swing application? I mean, I think I've done that probably 100 times. And every time I did it slightly different. Or a wizard. I built so many wizard frameworks for Swing, it was just ridiculous. So some of those things that are common elements are already done for you. They have a very decent look and feel. It's customizable, but it's pretty close to what the platform expects. So if you're on Windows and you do an Eclipse RCP application, it sort of has that look and feel that a Microsoft Office application would have. So users feel used to it. They feel comfortable with it. So again, you have things like viewers, editors, dialog boxes, tables, lists, and wizards in JFace. So let me give you an SWT and JFace demo. For this demo, I created a component that kind of looked like the Microsoft Outlook bar. You guys remember that bar on the slide that has collapsing menus and buttons? So this is a screenshot of one. This is not the one I built. But that's kind of the idea. You have collapsing panels and then buttons in there. And if you collapse this section in here, you will get scroll buttons or scroll bar. So I have my project here. In my project, I have a Outlook bar component that is a composite. That's an SWT class that it's kind of like your J component. So in one of the things about SWT is that to build something that's going to live in another component, you have to have the parent instantiated. So and you also have to deallocate the resources for things that have operating system resources, like a Windows handle or something like that. So it is closer to the way we used to develop UIs with Delphi or Oracle Forms or something like that. Now, in this demo, I have other things like a folding panel, which is the part that collapses, and I have the Outlook icon. And then I have a demo application that uses JFace application window to run my demo. And that's where I create some actions and I add images to the specific Outlook bar. So here's the list of images that get created. So again, working with SWT and JFace is not that much different than working with Swing. It's actually simple. And that's one of the things I like about the framework. So in here I have a definition of how I'm building that Outlook bar manually. So now, if you notice those items, those are the three groups that you would see in the demo. And of course, I have an action that brings up an about box for that specific demo. So now I can show you the demo running. And again, like you would expect, you have scroll buttons rather than a scroll bar. You have the icons, and then you have the collapsing panel. Doing this in SWT, I would say it's probably half the effort of doing it in Swing. So just even from the core components and the core pieces of your Eclipse RCP application, the model is much simpler on how to build applications. So now that we see some of the foundation technologies for Eclipse RCP, let's take a look at some of the basic concepts of Eclipse RCP. So again, RCP is a platform for building native-looking Java applications. So if you're running on Windows, it's going to look like a Windows application. If you're running on the Mac, it's going to look like a Mac application. If you're running on Linux, it's going to look like the Linux application. And it all started in 2003 out of the Eclipse 2.1 code base. And what a lot of people in the community started seeing that, hey, I want to build an application, but I want to reuse some of the parts of Eclipse that are common, that I don't want to keep on reinventing. So a lot of people put a lot of effort to break those away from Eclipse and turn them into plugins, into specific components that can be reused. So today, Eclipse, it's an Eclipse RCP application. It's probably the most widely used Eclipse RCP application. But it's a good example of eating your own dog food. So They created the framework. The most used application on that framework is the actual IDE that you use to build the application. Also, Lotus Notes 8.0, it's now an Eclipse RCP application. And if you can think about, anybody use Lotus Notes for work? Well, Notes, I know you're from IBM, so I'm gonna have to bash IBM for a second. But when it comes to UI design, Notes was probably the most outrageous application in terms of violating every rule of good UI design. Well, what happens in a Windows application when you press F5? When you press F5, refresh, huh? You know what happens in Notes? It logs you out. To this day, and I worked at many places where I get to use Notes, and every time I move away from Notes and come back, I'm like, oh, I'm going to refresh it. Ah! But again, you guys gave us a microchip and a lot of other good things, so thank you. But the fact that IBM is putting Notes on their RCP should give you an idea of the level of confidence that they have on the platform. Because Notes is not a simple application. It's a platform for building other applications, and it has so many moving parts that it would have been a foolish decision to try to build it with Swing, because you would have to reinvent a lot of things from the ground up. And that ability of having plugins that can turn themselves off and turn themselves on when needed, it's critical for an application of that size. So the implementation of the plugin framework, it's the Open Services Gateway Initiative, the OSGI framework. And that's a framework for defining plugins and components and application bundles in Java. And Eclipse RCP has probably the first implementation of that framework. So RCP, again, it's a bunch of plugins that work together to accomplish what you see in Eclipse IDE and other applications. So the OSGI gives you all that plugin functionality, the lazy loading of plugins, bundles, services. The runtime plugin gives you the extensions, applications, and products for the platform. The UI gives you everything that we see in terms of actions, perspectives, views, editors in the actual workbench. In JFace gives you the model-driven widgets, and SWT the close-to-the-metal raw widgets. So this is sort of what the Eclipse RCP framework looks like. You have the UI that works with JFace, which works on top of SWT, and then you have the runtime and OSGI controlling what is active under the covers. So let me show you a couple of screenshots of commercial examples, and these are older screenshots of Notes 8 when it was in pre-alpha. But it should give you an idea that now Notes sort of looks like it belongs in the Windows platform. Every time I used to run Notes, I'm like, this thing looks like a Swing application. It just doesn't feel like it belongs in here, even though it wasn't a Swing application. But so the application, and this is not a very good resolution screenshot, but it should give you an idea that it feels more like Outlook and something that belongs in Windows. But even when you run it on a Mac too, some of the components take the look and feel of the Mac, so it feels like a native application. And here's a couple more screenshots. But again, this is not the type of application you want to build with Ajax. This is the type of application that if you build with Ajax, you're going to spend the rest of your career maintaining. Here's another commercial example, and this is a stock trading platform. And this is, again, the typical example of an Eclipse RCP application in action. You have a lot of things changing dynamically on real time. You have graphs and charts. You have tables of data that's changing all the time. So that's the type of application you want to target with something like this. So that leads us to talk about the demo for the application, for the RCP framework that I put together, which is a Tetris game. I didn't want to do a business application because I'm just so tired of it. So what I did is I created a Tetris clone. And of course, I'm really lazy, so I went out there on the web to try to find a Tetris application written in Swing so I can show how to port a Swing application to SWT in JFace and RCP. So I found an application that was a Tetris game. Then I rewrote all the Swing-specific parts as standalone SWT applications. This is the typical pattern. You start writing SWT composite components or JFace composite components. And then I merged that standalone SWT JFace application into a view for my Eclipse RCP application. And what that gives me then is I have auto-updating at my disposal if I want to. I have, you can have a front page with the, you know, when you start Eclipse, you get an HTML page that tells you, a guided tour of the application where you can have that too. You can have about boxes, dialogues, wizards, all those things now are available to me in this application. So to show you the project structure, in Eclipse RCP application, it's just an Eclipse plugin that happens to expose a view, a concrete view. So in my application, I have 4 packages. I have a Tetris package, a Actions package, a model, and SWT. And also, you would see that every Eclipse plugin has other plugin dependencies. In the case of an Eclipse RCP application, the plugin dependencies would be the plugins that make up the Eclipse RCP platform. But imagine that you want to use something like Hibernate. Well, you can turn Hibernate into an Eclipse plugin into a specific version of Hibernate into an Eclipse plugin and make it a dependency of your application. And there's a lot of plugins already packaged like that. For example, you can do full text searching with Lucene, which is a free text search engine in Eclipse. That's what Eclipse uses when it does a search. Well, you can reuse that in your application if you wanted to. Of course, being a visual application, you have icons that you can replace and customize, and you have a lot of things that will give you the branding of your application. So in that first package, I have a few classes, and all these classes are generated by the wizard in Eclipse when you create a new Eclipse RCP application. You can then go in there and modify things to do specific things you want to do in your application. But you have something called the activator, which manages the plugin lifecycle of the application. It has a start, a stop, and things of that sort. Then you have, there's no main method. Again, because remember, you're running in a framework, so there's no class that has a main method you're going to run. Eclipse RCP gives you the application class that has an entry point in there. It has to start the application, to stop the application, things of that sort. Then a common theme in Eclipse RCP applications is that you have advisors. So an advisor is a class that tells a part of the framework how to behave or how to customize itself. So you have advisors for determining the initial size of the application, whether you're going to, let's say that the user resizes the application and then closes it. Well, would that size and position be saved? So some of those things you can do with some of these application advisors. So one of those advisors is the application window workbench advisor, which determines which elements you're going to have in there. Am I going to have a toolbar in the application? Am I going to have a cool bar? Am I going to have a status line? So you can basically tell Eclipse, I want this, it's like a shopping list of what you want to see in your application. Then, of course, just like Eclipse, you can have multiple perspectives. Most applications, you would have a single perspective with probably multiple views. In this application, I only have one perspective that determines the view that it will be loaded. And of course, I have my Tetris view, which is a view part, which is a class that is part of the framework that wraps that SWT application that I wrote for the Tetris game. So of course, I have actions. Just like in Swing, you can have an action that can be reflected on a toolbar, on a menu item, on a specific button somewhere that carries with it icons and all those things. So for my specific application, I have something called a new game action, which is a JFace action that will start the new game of Tetris. Then, of course, the model is all the non-UI parts of the application. And I have a definition of a board, a score, a list of scores, and a stone, which is the specific piece of the Tetris game falling down to the bottom. And I have a package that's called SWT, where I have all the specific UI elements of the application. So let me jump and show you the application. So there. Okay, so of course, since I can't see that in here now, but so here's my Eclipse RCP Tetris application. And like I mentioned before, there's a few packages in here that are generated by the wizards. So in this case, here's the activator that controls the life cycle of the plugins. And notice that it has a start and a stop. And then you can add behavior in there if you need to do things before the application starts or after it stops. Also, here's the workbench window advisor, one of the typical advisor classes that you have in Eclipse RCP. In here, notice I'm extending a class from the framework, and I'm doing things, and this I added myself, like, for example, set the initial size to 640 by 480, which, if you're forced to use 640 by 480, you probably upgrade your hardware, but I still have that burning to my psyche since the 90s. So I'm also telling the application that I want to have a cool bar, and I also want to have a status line. So a lot of this code is generated for you, and you only have to go there and modify what you need to modify. Again, my application has only one perspective. In that perspective, it's creating one editor area for the single view that I'm going to have in there. And it's setting the fixed value, the fixed size for the layout, and it's saying that I have only a standalone view, which is the view of this ID. Of course, if I open that view, you can see that that is the view part, and inside of that, I have my original SWT Tetris application. So building Eclipse RCP doesn't have to be intrusive from the beginning. You can build everything as individual islands of functionality and then weave them together in the Eclipse RCP framework. So also let me show you, here's the action that starts a new game. And this is a class that implements a JFace action. And you can see that I added a specific icon to my action. Notice I did this programmatically here, but I could do this from a configuration file in the whole plugin has a lot of XML files and property files that you can configure to brand things differently, so you don't have to change code. So for example, if I had an application that had multiple languages, just like a resource bundle, you can have all those things externalized from the actual code. In this case, I was lazy and just did it right here. But my application actually has two actions. One of them is programmatic, the other one is an action that's defined only configuration, which is my about action. So notice, when you build an Eclipse RCP application, you get this nice view that shows you an overview of your application. You have buttons to launch it in run mode and debug mode. Also shows you the dependencies that you have. In this case, I have dependencies on the UI and runtime plugins. It also shows you runtime dependencies. So if there's something that you're only using at runtime and you want to dynamic load that component, you can do it there. And one of the very cool features of the Eclipse RCP platform is that it gives you extensibility. So you can create mini platforms. So let's say, for example, that I wanted people of using the Steppers game to add their own graphics to change what the stones in the game look like. I could create an extension point for them to add specific classes that implement an interface so they could change the look and feel of the game. So that's where, in corporations, this fits fairly well because you can create an API that sort of matches the business that you're in. Let's say it's insurance. You can create extension points. So you would have, for example, something based on the IBM insurance IAA framework. And then you can have different departments of the company customize that for car insurance or for homeowners insurance or other types of insurance. So it gives you that pluggability and that extensibility that it will be pretty hard to do from the ground up in Swing or something else. So notice in here, in this view of my extensions, I also can see the things that I can customize. Notice in here I have an about image, and I created an about image for my about box. So I can change all that in here. I also have the text that goes into my about box. So this is a typical pattern in Eclipse RCP applications. You get a pretty standalone vanilla flavor look and feel and branding of your application. And then in properties, you go and change everything that you need to customize. So let me show you. Of course, you notice that I have only one view in my application. And if I had any extension points, they would be shown in here. So now let's run the application. We can take a look at what it looks like. And then I'll show you some of the model parts of the application. And of course, this might launch somewhere else that have multiple. Yeah, let me, you're missing the about box, so I'm gonna switch my computer to stop mirroring. Okay. Let me do that again. So I'm launching my Eclipse RCP application. You see that I had an about box that I created specifically. Notice that I have two actions. I have one to start the application. My about action doesn't have an icon, so it's just showing the text, the short text for the action. If I click that, this about box was created for me by the Eclipse RCP framework. All I have to do is provide the image in that text. Of course, I should probably wrap that text so it doesn't create such a big about box. And of course, you have typical things that all these things you can turn them off. So for debugging, I like to keep my plugin details button turned on so I can see what plugins are being used in my application. And notice in here that I have all the Eclipse RCP components, and then I have my Tetris plugin, which is the actual Tetris application in RCP. So that's the way everything works in Eclipse RCP. It's all plugins. Even your application, it's a plugin that happens to be using the RCP framework. And of course, I have, you can sign your plugins and have versioning, so people can use a certificate to make sure that you're providing a plugin from a reliable source. So all those security thoughts have been placed into the framework. So of course, if I notice I'm running on a Mac. So on the Mac, you have your menu separated from your main window. So in here, I have my action reflected here too. And my about happens to be under the hill. So if I run this, of course, oops, sorry, it didn't crash, it's just on the background, there it is. And of course, I'm the worst Tetris player in the planet, so I don't know why I picked Tetris as an example, but again, I did this in one night, by the way. It wasn't for this presentation, but it was, a few months ago, but I haven't done much to it ever since. But it was very simple to take a complex string application, turn it into a, never mind, I'm gonna play it here. Turn it into a SWT application and then use that to place it in the RCP framework to have a full-blown application where I could have self-updates, I can have extension points where other people can collaborate into the application. So there's a lot of things that have been done for me in here that I don't have to reinvent the wheel again and again and again. So let me show you another example here that I didn't have in the slides, but that should give you another idea of the type of things that you can do with Eclipse RCP. So in this example, I started building a address book type of application. And if you notice here, I have a single view right now, which is a context view. And in this context view, of course, I'm using dummy data, but imagine this could be talking to a real database using Hibernate or JPA or something like that, or straight JDBC if you wanted to. And I'm using a lot of the model view controller type of components from JFace to show this data on a view. And let me bring the plugin window so I can show you this running. But again, just in this one, I didn't customize anything. But you can see that you started here. I have a simple application that is displaying Java object, the toString of a Java object, into a JFace table. So it's very simple list sort. So it's very simple to do the same things you used to do with Swing, but in a much simpler fashion. So, in closing, why should you think about using RCP? Again, it gives you a platform for innovation and standardization in your company. So no longer will you have islands of different applications built in different technologies. You can now have plugins that can be composed into specific applications, specific departments, specific clients. Having a consistent look and feel usually helps too. Even when my wife, she is very dangerous with her computer. She would get on the web and find software here and there, and every once in a while she will get a Java Swing application. And when she runs it, she's like, Brian, I think it's one of your Swing apps, one of your Java apps. It looks kind of weird. It's doing weird things. And I'm like, how do you know that that's a Swing application? Because there's a lot of poorly written Swing applications out there. But to build a really good Swing application, it takes a lot of effort and a lot of knowledge. So providing common application services is definitely something that you want to look into for an enterprise. Given with Eclipse RCP, you can build applications like iTunes or any of the RSS feed readers or any type of cool-looking application. But the main strength is for the enterprise, where you want to have consistent look and feel, and you want to have a way to reuse the software, which has always been one of the utopian dreams of software development. And to this day, the most used form of reuse is copy and paste, which is the worst thing to ever do. So this is a good way to avoid things like that. So again, concentrating on your core business, never having to build an about box again, or a wizard, or all those things that should be standard dialogues. Some of those things that should be part of the platform are there now. And probably one of the biggest strengths is all the collection of plugins that exist out there for doing searching, for doing graphics, for doing everything you can think of. There's probably an Eclipse plugin or bundle out there for you to use. How are we doing on time? If we have more time, I'll show you guys another demo. Yeah. So I'm going to show you a couple more applications that are commercial, not commercial, but open source Eclipse RCP applications that show you what you can do with Eclipse RCP. And some of these I just downloaded last night because I was looking for something that I didn't write. So here's one. This is, sorry, let me turn the mirror off again. So here's an application that it's some sort of video viewer or something like that. It's called Azurus. But again, it's something like iTunes. This is built on Eclipse RCP. Some of the things that you might notice is that, for example, you have check for updates. That looks familiar. And of course, they decided to keep it that way. But you can hide the things that are similar to Eclipse, the IDE, the platform. You can, for example, do that on startup automatically without having to show them a menu item. So all those facilities are there on the back end for you to use. You don't have to expose them the same way that Eclipse, the IDE does. But again, this is an application that does not look like Eclipse at all. But it's built on the same framework, taking advantage of all those capabilities. Let me show you another one here. I guess there's no content filter on that, but I found another one. I don't remember the name of it. Somewhere here. Should have probably written that down on some piece of paper somewhere. Oh, yes. This one. This is an RSS reader that I found. It's also an Eclipse RCP application. And it actually looks fairly native on the Mac. Which, if you ever build software for the Mac, you know that it's not easy to get an application to look right on Mac. Well, it's somewhere in there. I'm not an expert at this application, so. Oh. But again, it can show you that, again, there's my about box for this application. Notice that they took away the other buttons that I have in my demo. So you can customize everything to the point that there's no hints that it is an Eclipse RCP application. It just looks like a Mac application. And if you run the same application on a PC, it will probably look much more like a PC application than your typical Swing app. Any questions?
What about mechanism distribution?
Distribution. Yeah, that's a good question. Eclipse RCP applications can be deployed via Java Web Start if you wanted to. You can also create an installer, but if you guys seen how you install Eclipse, you just basically drop the Eclipse directory, and there's an Eclipse exe, there's an Eclipse executable for each one of the platforms. Well, RCP creates the same structure, so you would have a native exit launcher, basically, for your application. Yes?
How does it compare to NetBeans RCP, which is the same?
Well, NetBeans RCP, it's a few years behind in terms of catching up with the technology. NetBeans used to be a fairly crude IDE. I love NetBeans nowadays. That's what I use for all my Ruby development. I use Eclipse for my Java development, NetBeans for my Ruby development, TextMate for both of them sometimes. But yeah, NetBeans has really improved in the last 4 years. They don't have quite a plugin framework that is as advanced as the one that Eclipse has. But yeah, I'm thinking that it's going to get there eventually. So you will have a choice. But again, making a Swing application look good is one of the hard things. For those of you that done Swing development, there's a framework called JFace. And those are probably one of the few persons in the world that can really take a Swing application and make it look like a native application. So it's much easier to get to that point with Eclipse technology. But yeah, I'm pretty sure that Swing will come up to speed in terms of having application frameworks, not only components.
Suppose if I'm developing not very small but not very large application, desktop application, is there a way I can pick and choose some of the components from the RCP?
Well, so what I use for that type of demo, that's the minimum subset of things that you can use. If you don't need about boxes and all those things in out of date, you can just do this SWT application. So the same way that you would do a normal Swing application. But you have the choice. So if you want all the other services, application services, you can use RCP. And normally that's the way we start. We do a standalone SWT JFace application, and then when we're ready to put them out there, we turn them into an Eclipse RCP application.
Is there a way that these two can talk to each other, Swing?
Yes, you can have Swing components in your Eclipse SWT application, Eclipse RCP application without any problem. AWT, you have heavyweight and lightweight components that kind of gets tricky in there. But yeah, you can have, if you have an investment on a Swing component that is sold by some third-party commercial provider, you can still have that in your Eclipse RCP application. I mean, it works seamlessly. Anybody else? Time to party? All right, thank you very much.